give a warm welcome to our keynote, YUKIHIRO Matsumoto-san, the creator of Group.
That's mine.
Good morning. I'm a little bit nervous. Last time I visited Europe, it was the RubyConf Paris in 2020, early 2020, and then the COVID pandemic happened. We are forced to have some kind of online conferences, but the biggest value of the conference is the networking, the meet face to face, and take a photos. So we're back. Yeah. Today I'm going to talk about my failure almost 20 years ago. And let me explain about the second system syndrome. Have you ever heard of the second system syndrome? Anyone? Okay, some of them. It's the first appeared in the legendary book named The Mythical Month. Its definition is that when one is designing the successor to a relatively small, elegant, and successful system, there is a tendency to become groundwise in one success and design an elephantine feature-laden monstrosity. It described the jump from the set of nice, simple operating system on the IBM 7000 series to the OS 360 on the 360 series. A similar effect can also happen in an evolving system. That's kind of confusing. It's quoted from the jargon file. When we create a nice system, for example, applications, languages, any software, but you know that we are not perfect. Thus, the system would not be a perfect system. It is nice, but not perfect. So we are tempted to create the second system because of we have some kind of historical mistakes or drawbacks or some design mistakes, so that we attempted to throw away the first system, then rebuild everything from scratch, trying to solve every imperfection at once. So have you ever felt that kind of temptation? We did. Okay, this is part of the human nature. So that every engineers, of course they are human, so that they are tempted to create new perfect system, throwing away the first system. At that time, we are imagining the second perfect systems, so we predict the perfect ones, fixing every drawbacks, mistakes, and have the perfect system without any mistakes, drawbacks. But as always, our estimation is too optimistic. You know that? So our estimation, like fixing the deadline, okay, this system will be finished before the deadline. But probably, usually, always, the project would not end at the deadline. So as a tendency of the human nature, so our estimation is too optimistic, always. Okay, the second system will be too complex, too time-consuming, requires to consume too much money, too easy to fail, too much troubles, so that we happens repeatedly fails. So that in the book of Mythical Month, the second system is the biggest mistake or biggest obstacle of the software project. For example, we once had a language named the PL1, which is the second system. This is very ambitious language because at that time, in the early 1960s, we had a programming language named COBOL, which is alive now. And we had the programming language named Fortran, which is alive now. COBOL is designed for the business applications, a common business-oriented language. The Fortran, the formula translator, is designed for the scientific computing. Both languages are still alive, still used in many cases. Okay, good. The users are declining, but still there. Some bank systems are still developed in COBOL. And some scientific computing, like astronomical computation or something, at least the part of them are written in the Fortran. Still, there are many supercomputers, like a top 500, driven by the Fortran programs. Still, the most of them. And but they try to create the second system, so that the language is good for the business application and scientific computing. So the perfect programming language for them. But you know that, have you ever programmed in PL1? Everyone? No one. So this is the fact. The second system would fail. Actually, when I was in school, I tried PL1, and I touched the surface of the PL1 program. It was a nice programming language, but not that attractive than, say, C or C++ or even COBOL and Fortran. Okay, the second system. Second system syndromes happens everywhere. Nearly 20 years ago, year 2000 to 2004, the programming language communities fell into the pitfall of the second system syndrome. I call it language renaissance. It started in the Perl community. Back then, Perl community is, expanding. It's the beginning of the web. The web applications, for the CGI, Common Gateway Interface, uses the Perl. Some of you may remember. And then the Perl community has a big popularity among the programming domain. But in the year 2000, so in the Perl conference held in somewhere in the USA, so that someone in the Perl core community shouted about the we are bored. He said, we're peak unless we can come up with something that will excite the community, because everyone's getting bored and going off and doing other things. So that if the community, member of the community, bored, then they leave from the community. Because we are open source community, we do not hire you guys. We do not pay for you guys. You just use the my language or Perl language because it is useful, it is exciting, it is wonderful, it has joy to use them. But if you guys bored, you're free to leave to, say, JavaScript. PHP, whatever. So that they try to start a new project to remove those historical words. And they collected the proposals from the community named RFC. So that they collected 361 requests for comments. And then the author of the language, creator of the language, who is the Larry Wall, compiled those requests into the documents named Apocalypse. Apocalypse. Whatever. We had 12 those books, documents to describe the future of the language. They named the new language without historical word, totally recreated from scratch. Then they named it Perl 6. At that time, the Perl was version 5. The next version will be Perl 6. This is a great challenge to avoid boredom, but it's a typical second system syndrome. Too challenging, too optimistic. We admit the boredom is the biggest enemy of open source software because people leaves. But or any project driven by motivation, the boredom is the enemy. The open source softwares are supported by the community. If community bored, they just leave. Open source software needs to keep moving forward. So we need to attract the community. We should avoid boring pitfalls. But we should avoid second system syndrome too. What happened to the Perl? Perl language? The first version of the Perl was released in 1986. Whoa. Perl 5.0 was released in 1993. And then last year, we saw the release of the Perl 5.38. What happened to Perl 6? We don't use Perl 6. Do anyone use Perl 6 right now? Do anyone know? Oh, you use it. Wonderful. you use the Perl 6 was renamed as Raku, which sounds like Japanese. And it's renamed in 2019. And still, very few people use Raku. Raku, the language, is wonderful. We have bunch of wonderful features, futuristic features in the language, but very few people use Raku. Yeah. I can tell that scrap and build is a bad idea for the bigger systems. Yeah. If your systems can rebuild in say 1 day, 1 week, okay, it's okay to rebuild, throw away and rebuild, but if your system is complex, big, to rebuild, rebuilding requires years, so the scrap and build is a bad idea. I can tell you, I can testify, but we didn't know in 2000. Python community did similar, unfortunately. They started the project named Python 3000. And then they tried to remove the historical word too. Unlike Perl 6, Python 3000 became real. The Python 3000 gradually became into Python 3. But still, because they removed the historical word, they lose compatibility. So some people they kept using Python 2 for years, actually more than 15 years. That's a tragedy because the core developers working on the newer version of the language, have many technical advancement, but the almost more than half of the Python community still using the older version of the Pro. And they supported older version because many people, more than half of the community kept using the older version Python 2. The 15 years of the community split was a tragedy. But year 2000, I think 2020, they stopped maintaining Python 2. Then whole the Python community finally started migrating to the Python 3 so that they merged. But it required more than 15 years for Python community to migrate to the newer version because of the second system syndrome. Okay. PHP community did similar things, mostly due to the improvement of the Unicode support. And then, along with the many drastic language change. But have you ever used the PHP 6? No one. Because PHP 6 was canceled before the release. And they started the PHP 7, restarted from the PHP 5. So that they failed and then they abandoned the scratch and build, the second system. We had similar things in the JavaScript 4. That they canceled the drastical change, the JavaScript programming language in the drastical change. The JavaScript 4 introduced the class and the namespace and many things at once, but they didn't keep the compatibility, so the community did not want to migrate to the newer JavaScript 4. The project was canceled. The JavaScript 5 was restarted from the older version of the JavaScript 3. I have to confess, we did too. In the keynote presentation in the Ruby conference 2003, which is more than 20 years ago, I declared the project of the Ruby 2, which is different from the Ruby 2.0, which we saw in 2013. Ruby 2 is a kind of the counterpart of the Perl 6 in the Ruby community. So that I once tried to restore Ruby without the historical word, just like Perl 6 or Python 3000, because it's before the failure of those projects. We corrected the RCRs, which stands for the Ruby Change Requests, and then they gathered ideas and discussions, and we had many ideas for the newer, restarted, the ideal Ruby, future Ruby. And we had a bunch of ideas: the selector namespace, keyword arguments, method combination, Unicode support, pattern matching, packages, the JIT compiler. I was too lazy to book the bookkeeping. So, like say, we have many proposals, ideas, and I'm sick of working with these kind of the paperworks. Like compiling some kind of counterpart of the Perl's apocalypse or something like that. And I get tired of managing them and give up the Ruby project. That was lucky for us. Then we had the Ruby 1.9, which is the gradual progress after Ruby 1.8. We introduced a newer virtual machine, and then we added the multilingualization, stands for M79. M79 stands for the multilingualization, which includes the Unicode support. And we did the gradual, but still incompatible change. The 1.9 was kind of incompatible. So that because Ruby 1.9 did not keep the compatibility, so that some people kept using the Ruby 1.8, the older version. And then we had some kind of the community split, like Python 2 and Python 3, but it lasts only five something years. Much better than the 15 years. Some people kept using Ruby 1.8, and they tried to use some kind of the boost version. Maybe some of you may remember the Ruby Enterprise Edition, which is the enhancement or the technical boost of the Ruby 1.8. But they gradually migrate to the newer version. 5 years are better than 15 years. But why we had short amount of time to migrate to the newer version? We have several reasons. We had the gradual movement so that we didn't throw away the older version, so that it's not really the second system. But the second and the most important reason is the new VM, YURV, is faster. Compared to the 1.8, 1.9 with YURV is faster in 3 to 50 times, depending on the benchmark. The 3 to 50 times faster makes people encourage to move on to the newer version. So the performance heals all sorrows. Slow migration of newer version, so that make them faster. Recently, we introduced the YJet compiler, which is wonderful. Actually, we introduced the JET compiler to the Ruby in 2.6. But that JET compiler is kind of experimental, because we had some kind of the CPU intensive benchmark, which runs 3 times faster compared to the Ruby 2.0. Wonderful. But with that JET compiler called MJET, with MJET, your Rails application runs 5% slower because Rails is a big framework, and Rails application have millions of methods, and the JET compiler requires to compile those millions of methods, so that the compiling time that sums up in the benchmark result, so that it makes the JET compiled performance even slower. But YJet is wonderful. We have many technological, say, revolution in YJet, and it makes your Rails application probably 20 to 80% faster. Now, this is the response time graph from my friend's Rails application. Red line is a release date. It's in Japanese, but the release date. So that before YJet turned on, and after YJet turned on, the response times reduced drastically. It's wonderful. And then the memory consumption raises up a little bit, probably 5 to 20%, but the response time reduced drastically. Wonderful. Anyway, back to the story. The scrap and build is a bad idea. We should evolve gradually. So that, remember, we had the Ruby 2 ideas: selector namespaces, keyword arguments, method combination, Unicode support, pattern matching, packages, JET compiler. And then now we have real keyword arguments since Ruby 3.0, method combination, we call it the module prepend. From Ruby 2.0, the Unicode support from Ruby 1.9, pattern matching since Ruby 2.7, the JIT compiler since Ruby 2.6. So that my dream features, most of them came true. The remaining one are the selector namespace and packages. Selector namespace is the kind of the method is rely on the namespace. For example, okay, you are the Ruby developer, but when you at home, you're maybe in the part of the family, your son, husband, father, or someone, so that you behave differently. This is the namespace. I wanted an object behave like a human, but in the Ruby conference namespace, Baltic Ruby namespace, you behave like a Ruby developer, and you at home, you behave as a father or something. That kind of things is implemented in the small script, which is the dialect of the small talk, and the JavaScript people try to implement the selector namespace in JavaScript 4, which is canceled, unfortunately. And then those namespaces can be provided in the packages. If you're the Python user, if you use the Python or Java, they have packages. The org.something. You can, isolate some part of the classes in some group of something named the packages. But in Ruby, our namespace is a global namespace. You create a class, you can see that class from everywhere. You can wrap them in the module, but the module can be seen in everywhere. We have no packages. That I want to maintainability, so that we want to separate some part of the application in a package, so that we don't have to worry about the name conflict, so that we don't have to worry about the dependency hell or something like that. In Ruby Kaigi 2024 held last month, we had the presentation to implement the namespace in Ruby, and which is kind of experimental. But this is probably the first step for these selector namespace and the packages. I'm expecting that that namespace experiment would be the key to the Ruby 4.0 in the future. Well, Ruby keeps moving forward. Later this year, we are going to have the Ruby 3.4. It will be faster and ambitious and conservative. Faster means we will have the YJIT improvement. The YJIT team are paid by the sponsored the Shopify, and the Shopify has the whole dedicated team for the YJIT development, and then they are working on the register allocation, the method inlining, and many other things. And then they told us the YJIT will be even faster in Ruby 3.4. That's wonderful. The other team in the Shopify also working on the memory management, so that they are working on the garbage collector. For most of the cases, we can ignore the garbage collectors, because the garbage collectors runs relatively faster. But in some cases, like allocating billions of objects for the request or something like that, so that we have to manage the those kind of the big memory space. And then the Java JVM has the option to switch the garbage collector algorithm for depending on the size of the memory of the access pattern, allocation pattern of the object. We are experimenting similar thing for Ruby, so that in the future we can add or switch the algorithm for the garbage collector in the say according to the access pattern of your application. In addition, so that you may remember the out-of-bound garbage collector for Rails. So the garbage collector was used to be slower than the current state. So that at that moment, so that we will do the out-of-bound garbage collection, which is the Rails application accept the request from the client, then process the request, then send back the response. Then at this moment, we kick the garbage collector explicitly to collect the remaining of the garbage from the request, so that you don't have to worry about the intervention from the garbage collector in the middle of the request processing. So that reduces the unexpected, the slower response. Since we introduced the incremental garbage collector and the generational garbage collector, the demand for that kind of the out-of-bounds garbage collection is reduced. So the out-of-bound garbage collection is removed from the Rails years ago. But since the nature of the generational garbage collector, we have two kinds of the garbage collection, which is the minor garbage collection, which scans only the younger generation of object, which tends to be the finish shortly. But sometimes we have to kick the major garbage collection. We have to scan the whole object space, and it takes much time compared to the minor garbage collection. So we are trying to implement the out-of-bound major collection. If we are close to the major collection, so the major collection, the interleave the response, the request processing, we kick the major garbage collection in the out-of-bounds. That would improve the responsiveness of the URLs application. So including these changes, we are trying to make Ruby even faster. So that in average, each year, URL applications runs 1 to 5% faster every year. That is wonderful. Whoa. Ambitious. We are going to add the new parser to the language. And then we also add the namespace experiment that I described a little bit earlier. I'll explain about this new parser later. After Re3 released, you can experiment about the namespace. For example, using this kind of the namespace feature, you can roll the two versions of the, say, JSON gems in the separate namespaces. Because the two namespaces are independent, so that in this namespaces, you can load the JSON gem version something, version 1, and then in this namespace, can load the JSON gems version 2 or something, even if they are conflicting. So that since the namespaces are isolated, so you don't have to worry about that. So the version conflict. And even though those gems lose the C extension, so you don't have to worry about the name crash because the namespace would handle those kind of the naming conflict. Well, the Ruby 3.4 is also conservative because we are declaring the syntax moratorium. Since we are developing the two browsers, and one is the current one, the path.y, and the new one is called Prism. And the Prism is chasing the current one in the quality and the feature-wise. So that to be fair, so that we suspended the syntax enhancement to the language until the release of the Ruby 3.4. So that if you propose the new syntax for the Ruby language in the bug trackers, it's okay to propose anything, but that would be suspended until Ruby 3.4 if it changes the syntax. Executive in the Intel Corporation once said that only paranoid can survive. So we want to survive. The Ruby community want to survive. I want to survive. Because, if whole Ruby community and the Ruby language dies, you can go to anywhere. You can go to the TypeScript, you can go to the Python, Julia, whatever. But what about me? I can't go to anywhere. I don't want to go to anywhere. We have to survive. So how can we keep Ruby alive for the next 30 years or 100 years? I have some goals. The first goal is to keep Ruby forever. So thank you. Thank you. I'm not going to add the type declaration to the language, no matter how they complain. I'm not going to make any big syntax changes to the language. No big semantic changes. But we need to progress because boredom is the biggest enemy of open source software. We keep moving forward. So the first domain is performance, because performance heals every sorrow. So we are working on JIT compilers, we are working on the memory management, we are working on the instance variable access, the object allocations. So we are improving performance. So we dedicate our effort to improving the performance. And thank you to Shopify and other companies to support us and hire developers and help us. We are making progress, and we are working on the concurrency. Remember that, when I started Ruby in 1993, more than 30 years ago, back then, every computer, with few exceptions, that most of the computers are single cores. Because one CPU is a computer. So that at that time, concurrency is a kind of the way to express some type of algorithm, like a producer-consumer algorithm or the broadcast algorithm. That it is not for performance. But now, we are in the multi-core age. We have a lot of cores in the CPU. This laptop has 8 cores, and in a server system, we have 64 core, 128 cores. Maybe near future, we have the millions cores available in the systems. So that at that time, the concurrency is for performance. But the Ruby is designed, Ruby is not designed, let me rephrase. Ruby concurrency is not designed for the performance. That we have to fix. The global interpreter lock is the kind of the victim of this complaint. Upon our survey for the language like Python, which is the data consumption language, for the data scientist, the global interpreter lock is the performance hindering performance. So that they try to remove the global interpreter lock in Python 3, I don't remember, 3.12 or something. But for Ruby, so we mostly use for web application. So that in web applications, the global interpreter lock does not hinder performance because of our bottleneck is the network and database, both I/O. So that the problem is the removing those idle time. So instead of removing GIL, we are working on the Raptors and the Fivers. Fivers we already had for years, but we are making the asynchronous the fiber operation. So that for I/O heavy task like a web application, that we can use fibers. The context switch of the fiber is far lightweight than the threads. So that we can use the fibers to do some kind of asynchronous work in Ruby. So that you can find the async gem from the rubygem.org, so that you can add the asynchronous things, asynchronous processing, without having the bunch of the async await things in the language. That's much nicer in appearance, and the performance is kind of the same. Okay, fibers. Raptors are designed to do some kind of CPU-intensive task. For web applications, we don't do much of the CPU-intensive tasks, but we still have some kind of needs for the CPU works. So the Raptor is for that purpose. Raptor stands for the Ruby actors. Then you can isolate some part of the task into the Raptor, and then you can communicate with those Raptors with the message passing. If you can remember the Alan and the Alexa, so that you can imagine the processes in those language as Raptors. So the Raptors are working on the threads, and we are working on the more lightweight Raptors, so that you can create the millions of Raptors in application, and then they run without having the global interpreter lock. And as fast as possible. So that for concurrency performance, we are going to have the Raptors and fibers. So and then the Samuel Williams, who is supporting these fibers, also implemented the application service named Falcon, which is kind of the counterpart of the Puma or Unicorn. And then the Unicorn uses processes for concurrency, and the Puma uses threads as a concurrency. And then Falcon uses fibers for the concurrency. And then as far as Samuel told me, the Falcon runs much, much faster than Unicorn and Puma. And that is kind of good news. In addition, some other guys in the Shopify also working on the application server named the Pitchfork, which is the next version and next generation of the Unicorn server. And Pitchfork relies on processes just like Unicorn, but runs much faster than compared to the Unicorn. Your next Rails application may consider about migrating your the application server to the next generation, like Falcon or maybe the Pitchfork. Anyway, in addition, we are working on the support tools because of these days, not just the language creates your developer's experience. Many years ago, we have the plain text editor, and we indent by myself, and we syntax checks by myself. No editor support, just type it. But those days, people hit tabs so often. The VS Code or any Copilot or any other tools supports, okay, this is error. In this place, you have the choice of this method, this method, this method. Or these kind of tools help us to improve our experience as a developer. So the supporting tools are as important as the language itself. So that we have Rubocop, Steep, Rubocop for linting, so that you can detect and then the error code in editing time, and the Steep and Solve It helps you the check types, and then we have a lot more tools supporting your development, and then we believe those tools would help you become more productive in Ruby. And that's pretty much important because for the other languages, especially the JavaScript, they have a lot of support from tools. They are providing many tools to improve the performance, productivity of the developers. That means so that even though the language niceness for the programmer varies on the language, okay, I don't say anything about the other language here, but no matter how good or how bad is the language, but with supporting tools, your experience will be higher with those tools. So that providing tools is very important. So that I want to encourage community to come up with those tools. So that as a core developers, we have to supporting tools. For example, we have the Prism, which is the parser, but a better parser for tools. Means we have the parser gem, which is the Ruby parser written in Ruby originally, but it is independently developed from the Ruby parser because of the Ruby parser is written for Ruby in C, and you cannot rip off the parser from the language virtual machine, then use those parser as a library. So that if the core developer, us, making some new changes to the language, for example, the pattern matching, so that they independently develop the pattern matching syntax to parse the pattern matching syntax to the language. Because they are independent, the they need more time to follow up new syntax. That's not good. We have some kind of redundant works. So that we want to have the Ruby canonical parser can be used as the part of the language, and also can be used as a library to parse the Ruby itself for tools like LSP server or the tools like Rubacop or formatters or whatever. So that it should be universal. You can access from within the language and from the tools, and it should be independent from the language itself, because when you want to parse from the Rubacop, you don't want to have the whole Ruby interpreter into the library or something like that. It should be independent. The third, but most importantly, so that when editing Ruby programs, it has errors. And for Ruby interpreter, it is easy. Okay, you have syntax error, we stop parsing here. But when editing the tools, the stopping in the middle of the program is not ideal. We have a lot of the programs follows after the error. So that we have to recover from the error to continue parsing after the syntax error. This is called error tolerance, which the canonical parser does not have. So that we have those kind of the good attribute to the new parsers. And then we have the Prism, which is the new parser. The Prism is used as the parser for JRuby, Truffle Ruby, and the parsing core of the parser gem now, and the more tools using the Prism parser. Prism work is also sponsored by Shopify. Now, Shopify doing helps a lot of works for Ruby, and thanks to Shopify. And we have Steep and TypeProf. These are the static typing without language changes. We are not going to add the syntax declaration to the language, but we are still collecting information from the programs, and we can do the static typing as much information we can have read from the program itself. And companies like Square, Cookpad, Stores, those companies, the latter two is Japanese companies, and then the help and the sponsors those works. We have many things to be done. We have still remaining a lot of things to improve the programming productivity, improve the productivity development, to improve the developer experience. So that if you have any ideas, so that you don't have to implement by yourself. Your idea matters. Just tell us. Just tell us through preferably through our bug tracker, bugsrubylang.org, and or maybe you can tell me face to face. But for the record, okay, if you tell me your idea in the hall, so that I might steal your idea. So for the record, it's better to submit your ideas to our bug trackers, because I have the original proposer of this idea or something like that. Anyway, okay, we have Ruby now, and we want to keep Ruby alive. Your idea and your opinion matter, so come join us to not just Ruby users, but idea providers or the opinion leaders, the Ruby community. Why we use Ruby? Because Ruby is a wonderful language. I know that. But I believe it's not the biggest reason. It's the community. Community is the reason. Community is the reason we use Ruby. the most precious treasure of Ruby, community. You are part of the community because you are attending this conference, Realtek Ruby. The community needs new blood. Attract young programmers. To attract young programmers, we need job and money. Keep Ruby attractive for companies. And the Ruby on Rails is one of the reasons the company uses Ruby. Rails first released in 2004, which means this year, Ruby on Rails is 20th anniversary. Happy 20th anniversary, Rails. Yeah. I'm not sure DHH would hear you. But 20 years, but still being state-of-the-art framework. Wonderful. And as so many people, companies use Ruby, and Ruby on Rails drive the society. If you check this website, toprubycompanies.info, you can see the many, mostly US-based companies and that use Ruby. But still, we have a lot of things to do. Still, we will keep moving forward. And we will lengthen our stride. We will create value as a community. So that if you create a value as a community, you work with Ruby, and you create services, softwares, and you can make money on it. That's wonderful. And then you can hire new people who use Ruby. That's more than wonderful. And if you help others, like organizing conferences, helping others, and then teaching younger people, wonderful. That's the community. That's the community that drives Ruby better. Come join us. Create a better future. That's the power of Ruby. Thank you. And this talk is sponsored by the NSCL, which is the Japanese company who hires me for years. And also OSS Vision, which is also a Japanese small company established this year. And I'm the I'm the CEO of this company, but it's only a small three-person company. And my work is sponsored by the GitHub sponsor. Thank you for the GitHub sponsors. Maybe something else. And the Shopify and JetBrains. And JetBrains recently started sponsoring me. Thank you. And then my whole activity is sponsored by the Ruby community. And then thank you for the Ruby community. As a part of the community, thank you. Thank you. Yeah. And attending the Baltic Ruby, and thank you for the organizer, and wonderful having wonderful venue and programs. And organizing conference is tough. I know that. And then thank you everyone to come join us. Thank you.